Hear these words of the great American poet James Weldon Johnson. And God stepped out on space, and he looked around and said, "I'm lonely. I'll make me a world." As far as the eye could see, darkness covered everything blacker than 100 midnights down in the cypress swamp. And God smiled, and the light broke, and the darkness rolled up on one side, and the light stood shining on the other, and God said, "That's good." And God reached out and took the light in his hands, and God rolled the light around in his hands until he made the sun. And he set that sun ablazing in the heavens. And the light that was left from making the sun, God gathered it up in a shining ball and flung it against the darkness, spangling the night with the moon and the stars. Then down between the darkness and the light, he hurled the world. And God said, "That's good." The universe was born as space opened up, filling with an enormous explosion of energy. This energy radiated out into quickly expanding space, cooling down, and within a fraction of a second, condensing into the fundamental particles of matter. It took hundreds of thousands of years for atoms to form. Enormous clouds of atoms are drawn together by gravity, spiraling inwards, crushing together, and forming massive solid bodies of high pressure and intense heat, causing nuclear reactions which exploded with brilliant light, and stars were created. Great collections of these newly born stars were drawn together, forming hundreds of billions of galaxies. Our home, Milky Way, is 100,000 light years side to side and 16,000 light years thick. The Milky Way spirals, making one complete rotation every 200 million years. Our solar system formed from stardust and exploded supernova. Gravity drew together this rubble, creating a huge spinning cloud of rocks and dust, at the center of which the cosmic material was crushed together, exploding into our sun. Our Earth began as a molten mass of rock. As Earth cooled, it formed a crust around its molten core like film on cooling pudding. Movements and eruptions in the Earth's surface produced mountains and valleys. The vapors from its boiling interior rose upward, cooled, and formed clouds of steam which condensed, and water fell. It rained for eons. Rivers, lakes, and oceans were created. Under the right conditions, carbon has a tendency to bond together with common elements to form long and complex chains of atoms. These organic molecules bonded with other organic molecules and were washed into the sea, settling into great pools of organic matter on the seafloor. In one of these pools, one of these complex organic molecules began attracting to itself all of the pieces that it needed to assemble an identical copy of itself. The copy then split away from the original and began to assemble its own new copy, and a powerful chain reaction was begun. After millions of years and countless mutations, new and more complex molecules developed a protective layer, safely contained within this cell wall. The chemical reactions became much more complex. It took hundreds of millions of years more, but eventually the instructions for how to build proteins were encoded in a molecule we now know as DNA. Some cells evolved the ability to use sunlight, converting common chemicals into food, producing oxygen. After millions of years of photosynthesis, the atmosphere became rich with oxygen. But oxygen was deadly to anaerobic bacteria, who were the great majority of living things. And this first environmental crisis was solved by way of a process of cooperation and mutual benefit. As cells gathered together, committed themselves to one another, they found that in community, their own survival and development was enhanced. Around 600 million years ago, The first multi-celled animals appeared, small, flat, worm-like creatures that absorbed algae through the outer layer of their bodies. Within a short time, the oceans were filled with animals that came in a multitude of weird and wonderful shapes and sizes. Around 500 million years ago, freshwater lakes had become fertile environments. Plants living in shallow water were able to gain more nutrients by anchoring themselves in the mud. Once anchored, they began branching towards the surface to collect more sunlight. And these plants evolved to growing branches permanently above the waterline. Around 420 million years ago, the first plants appeared on land, and once they had taken this step, there was no turning back as they spread out across the empty continents. They were followed soon by insects, then amphibians, reptiles, and coniferous trees came later, and eventually the dinosaurs. Around 65 million years ago, a massive rock slammed into the earth, incinerating everything within a 1,000-mile radius. Forest fires and volcanic eruptions sent thick clouds of dust and smoke into the sky, blocking out the sun. As the sunlight faded, the temperature began to drop. Plants withered as they were starved of sunlight. Food became scarce. All of the large animals died, as did many of the small ones. The only dinosaurs to survive were the birds, able to fly above the carnage and search for scraps of food. Small, furry mammals survived as well because they could adapt to cold conditions. They could move faster over longer distances, more actively search for food. They could hunt any time of the day or night in any season. They evolved hairs on their skin to retain body warmth and an extra layer of brain tissue to override their instinctual behavior so that they could learn new skills. Around 7 million years ago, some of these mammals, ape-like creatures, moved away from the forest where they had evolved and began covering the grassy plains. As they spent more and more time traveling in open ground, evolutionary pressure favored those with longer legs, and they began to walk upright. Their hands were no longer needed for walking. They could be used for gathering food or using sticks and stones as weapons, which enabled them to hunt larger animals and carry the meat back to feed to the rest of the group. Around 1 million years ago, they learned to control fire and cook meals, and perhaps no more than 50,000 years ago, they developed the ability to create symbols called words to convey abstract ideas, including this one: the heavens declare the glory of God, and the firmament showeth God's handiwork. Last year, the United Church of Christ issued a pastoral letter on the relationship between religion and science, and it opens with its own words of amazement and praise. Through the scientific advances of our time, we are seeing nature with new eyes, and what we see fills us with wonder and praise. Stunning images of deep space are like new windows on creation. Microscopic details of living cells show us the unexpected intricacies of our biology. Mathematical equations unravel the secrets of the first seconds following the birth of the universe. Through these gifts of science, we look across ever-expanding vistas of cosmic beauty, almost to the beginning of time itself. What we see evokes wonder and humility, and we hear within ourselves a new voice arising and singing an anthem of praise that reverberates through the whole of creation. I personally see very little difference between the James Weldon Johnson poem and this evolutionary history that I just told you, which, by the way, I adapted from a handful of online resources, including material by the evolutionary theologian and evangelist Michael Dowd, who was speaking here in Oklahoma City last week. He led what basically is a Unitarian revival.